Um, See, there's a lot of places that logs can come up on your test, like from like part 1 to part 4. They can kind of be like all over depending how they're asked. So we're going to go through like all the basic ideas. And the one that comes up the most is when you guys are changing from log form to exponential form. And what we used was this idea of like day. So whenever you guys are asked to find something or find x, but you're in log form. So if you have anything in log form like this, it has the word log with it, what we have to do is change it into exponential by doing b, a, e, the big. So the little part becomes the big number. The exponent always goes on the base, and then it equals the answer. So if you guys are going to find x here, you can't just type this thing in, you have to use big. So when you guys reverse it, it becomes 9 to the 3 halves equals x. How would we do it from there? Really what I do? And your calculator. Great. Just make sure that 3 halves is here. We need parentheses around it. So 9 to the 3 halves. We would get 27. Alright, why don't you guys try this next one? We're going to try to find x here. Before we put in the calculator, we can take it. Oh, it's like maybe the new little application, but
No, kind of well.
If you don't like it on the left side, if it makes more sense to you guys to see it like log 2 9 equals x, you would do that.
What's the special thing there? Is it like alpha?
It's like alpha y equals or alpha window. Is there a shortcut? If you guys, so there's a couple ways you guys could do this. One way is easy, one way is pretty tough. So if you try to do big here, you would have 2 to the x equals 9. Now, does 2 to anything give us 9? Like 2 squared, 2 cubed? Ugh, goodness. Okay, so one way that you guys can handle this, right, is if you have an updated calculator, right? The updated calculator can give you this part and then what it equals. So if you guys type in, with it, alpha window is like a shortcut, which you can Angie I'm sure works, but this is just a short
You go
little.
into math and then you go down.
Math, and then which one?
Press the up button. And then okay.
Oh yeah, so you could do log base too. Perfect. Yeah, either one that you guys want. So if you wanted to do math and then go to choice A, right? That'll work. So all you would do is type in what you had. You had this was a 2, this part was the 9, and we didn't know what that equaled. So you could just type it in like that. So 3.1, oh sorry, 3.2. You're on in there is 10. Now the other way, let's say I didn't have that nice little application, right? You guys, you could not get the bases to be the same. What you could have also done was take the logs of both sides. So if you took the logs of both sides though, where would the x go? Where would it move? Oh, you poor boys, I forgot you can't talk today. Alright, yeah, so the x moves to the front because your exponents with logs move to the front. Now, if you wanted to find x, how would you separate what's going on here? Divide, good. So you could divide by log 2. So if I needed to take log 9 divided by log 2, log 9 divided by, let's close my parentheses, divided by log 2. So we get the same exact thing, right? So that nice little calculator option really helps us out pretty easy.
So you don't have to do that long.
Right, so you don't have to do all this. Pretty cool. Okay. One thing I wanted to put on here, you didn't. Do you guys remember if I gave you guys something like y equals 2 cubed, and you said put into log form, like going the reverse direction. Like instead of going from log to exponent, we're going from exponent back to log. You guys remember how to do this type of a rewrite? This was a little bit tougher when you're going back into log form. What you want to think of is if you're going from exponent into log, right? When you guys go into the log form, you start with your log, and then you kind of want to work backwards that this is the base, then the answer equals the exponent. So up in this part, what's the base? 2. So 2 becomes this little number down here. What's the answer over here? Y, good. Equals the exponent, which is 3. So this would be it if you're going into log form.
This kind of looks familiar to you guys.
A little bit. The only other thing I just want to talk about before we move on, and I kind of forgot what the name of this off. I don't know. I should have closed junk on here. If you were going to graph a log, right? Like if I was going to graph, let's say, y equals log, I don't know, 4x, something like that. Okay. If you were to graph this in a calculator, graphing logs like never shows up, but just in case, just a quick little refresher, you want to use that special key in the log button, right? So you want to use math, and then press and spell math. There we go, math. And then want to use A where it says log base. Okay. So when you guys go to graph this, we would start with our y equals. But when we type this in, you can't just use the regular log x button because this log doesn't have the little option for the base. This is only for base 10. So to get that little special base there, right, we're going to have to go to the math key, go up to choice A, that log base. Then you guys can actually like type things in now. So you can put our 4 in, air it over, put your x in. Then if you want to graph it, do get on my tree part. So move 6, open it back, open it. Okay, you guys are in something straight. Did you guys get something that resembles that? Oh, you don't have the A option? Alright, so we have to update it.
Yeah, I think mine is up now.
It is updated on yours. Okay, good. So you know, do you know that button?
Yeah.
Good. If you guys didn't have that button, you have to use the change of base formula. I mean, I don't even know if you guys would remember that because if you have the option, it's so much nicer to put it in. You have to do log 4 over log x. Remember that you had to take the little part that was like the big part up top. So if you graph it like this, you have to do log 4 log x. Oh gosh, what did I just do? Maybe it's log x divided by log 4. That's not the same. Yeah, let's see if this will work if we do that. Yeah, I think it's the opposite. There, yep, it is. Okay, so, sorry, rewrite that part. So this would be log x. Log 4. So the thing. Oh, actually, no, you can remember this, like this close to the bottom because it's lower. It's kind of lower. That would help you remember. But that's how you would have to do it if you guys didn't have that like special little math key. Right, but use the math key. It's obviously way easier to just take it in. Well, if anybody has a calculator that needs to be updated, we'll make sure we do that. Everybody else is good? Yeah. Alright. So log rules is a pretty big concept. When you guys were going through, this is probably like what you would see on part 1. They either do something with day, something with log rules, they like this kind of stuff. Just a little refresher, when you guys were doing log rules, multiplication and addition went together, right? Division and subtraction were together, and all exponents get brought to the front. But you guys never saw your exponents radicals. So like if you had a square root, it was written as an exponent of 1/2. Do you guys remember what if you had a cubic root, what that one would be written as? 1/3. Good job. Right. So you won't see like radicals and fractional exponents are kind of rewritten as each other. A weird concept with log. So if you're going through your log rules, okay, here we're going to go from one log to lots of logs. We're going to expand this thing out. So if they say something like find log u, it just means that they want you to start taking the log of each part of this. So log u would equal, and you want to go through it in order, right? So start with your log f, and then what would division mean?
Minus.
Minus, good. And make sure before every single letter, or even just like a plain number, you guys have a log there. So we have another log y, but where does this exponent of a 2 go?
In the front.
In the front, good job. So it's moved in the front of that log y. Right? Just make sure the 2 should only go in front of the log y because the exponent's only with the y. So just be careful when you guys match up. Make sure it actually looks like it because it's very easy to pick the wrong one here. So it should be choice 4. Do you guys remember this stuff? A little bit? Right. Now this one's going the opposite direction. So you're going from lots of logs to one log, but it's the same idea. Why don't you guys see if you can figure out which one it's going to match up to? Does the pen work? Or sorry, pencil? Well, actually, I got a pen.
Wait, what's do you want me to just like state those separately, or can I?
No, you can write them like that. I took it's fine.
Okay.
But on the Regents, you want to do like what A is, B is, C is, and then A is.
Okay.
They're very like put together. A lot of people didn't do that, so I just thought.
Okay.
Well, how did you guys write a 1/3?
Is it a radical?
It's kind of radical. Cubic root, yeah. Because if you saw something in the front, it was really an exponent. We don't write fractional exponents. You guys are going to see them like the radical. So we would have log the cubic root of n. The minus means division. We have another 2 out in front. So before it goes out in front, it had to be an exponent. So n squared, which would give you choice 4. How'd you guys do that one? Most of you get that?
Yeah.
Great. Now, parts that are pretty tough, okay, are they like log equations. I've seen them come up quite a bit on part like 4 for 6-point questions. And there's 2 ways that you guys would see this, right? One way is when you have logs on one side, and one when you have logs on both sides. In the procedure, it starts the same, but then kind of goes differently. Either way, when you guys have a log equation, notice you have an equal sign. If you have logs on only one side, what we want to do is create a single log using our rule. So on this left side here, there's more than one log here, right? So we want to use our rule and make just one log. So we'll start with our log and the little 9, right? The 9 is joined with the log. Right? Then we have x. What does addition mean we should be doing though? Good, multiplication. Now the idea that we just change into using our properties or rules was so that we don't have to write this log every single time. So we're going to times this by what's the next thing you guys see? X minus 8. Good job. Perfect. Okay. So you know those parentheses, they kind of keep the long properties out. All right. So now, once you guys have a single log, if it helps you, if you would rather do this multiplication, you can. So log little 9, this would become x squared minus 8x equals 1. How did you solve something when it was in log form, but you needed to find x? What did you have to turn it into? Bay, yeah, who is that? Gossip, right? You had to change this into Bay. It was the only way that we can go from log form to exponential form to find x, right? And again, these are like big point questions, so they're going to be a couple steps, right? You guys see that. So when we do Bay, right, the base is that little 9. You have a huge chunk as the answer. So 1 is the exponent. Now when we rewrite this, it becomes 9 to the 1 equals x squared minus 8x. What is 9 to the 1? 9, good. So you just make this 9 equals x squared minus 8x. How do we have to solve this for x? What do we have x squared? That is 0. Good job. So minus the 9. Bring that over. Equal to 0. Any other ideas? Double bubble. Good job. Right, so x squared is x to x. Do we have factors of 9 that can make an 8? Minus 1, good job. Since you want a minus 8, you need a negative 9 and a positive 1. What do you guys have to set both of these equal to? 0, good job. So x is going to equal 9 and x equals a negative 1, good. Now one thing that is really, if they want to be really mean on the Regents exam, you have to remember to check these, right? Right, so when I say check, we cannot take the log of 0 or the log of a negative number. Like if you try to do log of, say, I tried anything, log negative 5, you get an error. Or if I tried to take the log of something that was 0, right, you get this error. So what we want to make sure is that when you guys look at your beginning part, way up here, where you see an x, right? If you put a 9 in here, 9 minus 8 is going to give me 1. Would you have to take the log of anything that's 0 or negative here? With a 9? No, so 9's okay. But look what happens when you try to do a negative 1. If I try to take negative 1 in here, negative 1 minus 8 is a negative 9. This is a negative 1. Can we take the log of those negatives? No. So we would reject the negative 1, right? Only the 9 would be an option. Well, what happened when I tried to do it by calculator? Yeah, errors, right? So that's just something if they want to be really like mean, they'll do that. And like try to catch people not like checking it back through. So only one of them will work here. So that's if you guys have a log on one side. If you have logs on both sides, like it's a little bit nicer. So right away you can tell like the difference between them. If I look on this one, I have logs like on both parts. On the other one, there's just on one side. So we're going to start off the same way here, right? We still want to get a single log on both sides using our rules. So let's start with that. So we're going to try this part to get a single log. We got our log little 2, we got an 8x. But what does subtraction mean we're going to do? Good job. So we're going to divide that. And remember, by doing that division, we don't have to keep writing the log over and over. So the only thing we have left is x squared minus 1. 1, 2, 3. All right. Now this is the best part. Once you guys have a single log on each side, we can cancel them out. All right, this is the nice part. That little 2, that little base 2 is connected with the logs. When you cancel them out, it's gone. And this can only be done when you have logs on both sides. So what we end up having is 8x over x squared minus 1 equals 3. What could you guys put that 3 over? 1, good. Right, and you have two fractions with an equal sign. Any ideas? Cross multiply, good job. Cross multiply here, good. Alright, so we take that and multiply through. 3 times x squared is 3x squared. Make sure it goes to both parts minus 3 equals, on the other side, 8x times 1 is, this is a good review for you guys. Alright, so we have x squared. What do we have to get this thing equal to? 0. Yep, good job. Okay. And keep this x squared positive, so we don't want to move it there. Let's subtract 8x. And make sure when you guys write it, you read it in standard form too. Right, so it's got the highest exponent and the lowest. Figure something. Yep, whenever it's an x squared, you always want to get a set equal to 0 to solve it. Actually, I would say x squared and anything higher than 1 you do. Like the x cubed to 4. So it's not going to 0. Okay, so we have 3x squared minus 8x minus 3 equals 0. Now you guys have some options here. Right? We want to find x. This would be a great example of a 6-point problem right here. What do you guys think to find x? You can do grouping method, yeah. What other way can you guys find x if you don't want to? Oh, there's one grouping. That's grouping. All right, did you guys in chat? What about quadratic formula? Can that give you guys x?
Oh, yeah.
Yeah, right, so you can use quadratic formula here too. Totally up to you guys which one you'd rather do. What would most of you guys do? Grouping. Okay. Alright, so you're going to do grouping method. Okay. We multiply the outside. This is actually good practice for tomorrow's lesson, what we need to do. So when you guys multiply the outside, you get a negative 9. So we want things that multiply to negative 9 but can make a negative 8 when we add or subtract them. What do you think here? 9 and 1. Good. Alright. Now if you want a negative 8, which one of these has to be negative?
9.
Good. Yep, and then a plus 1. Perfect. So with this kind of grouping method, what we're doing is, right, we're going to be taking our 2 and we're going to get rid of the middle one. We're going to put that in its spot. Because negative 9 plus 1 is still going to be negative 8. It's just a different way to write it. So we have 3x squared minus 9x plus 1x minus 3 equals 0. You guys remember from here where to go? Right in the middle. Good job. You got it. Okay. So we split it down the middle, and now we want to take the GCF of each part. Anybody know what the GCF of the first part is? 3x. Nice. Okay, so when you divide each of these by 3x, we should get an x minus 3. On the second part, make sure you guys take out the sign as well. Right. What's the only thing you can pull out of this? 1. Yep, so do a plus 1 as the GCF. Now when you divide each of those by 1, it's still just x minus 3. Make sure when you do your grouping, the bubbles need to be the same. So we're going to take both of these GCF, join them together. So 3x plus 1. How many times do you guys write the bubble? 1. Good. Okay. Now your last step, we still need to solve for x. You've got to take both of these and set them to 0 and solve them. Okay, so if we took 3x plus 1 equals 0, and minus 1. And oops, sorry, we divide by 3. So we should get a negative 1/3. And then this one's nice and easy. Just be 3. And still the last thing, when you guys do these equations, you still need to check them. So let's go back up and make sure that none of these will give us 0 or a negative number. Alright, well, if I put in a 3, is 3 going to make any of these things negative? Or 0? The first one will? Oh, goodness. And Jay, I think you're right. Yeah, because if we did 8 times negative 1/3, that's definitely going to be negative. Right? So if it bombs in one of these, it's like ruins it for everything. Okay? So you can't use this one. So just make sure you're careful with the checking. Right? They'll try to get you. That would be a great 6-pointer. Okay? Definitely does you guys get something like that.
Good afternoon. At this time, all staff signed up for the Google Lab training. Please report to the high school computer lab. Thank you.
Okay, so I have 2 more for you guys. They're pretty tough ones. We just haven't done them in a while. So let me let you read this first. We did that with exponentials, but they were like easy, not like when you were looking for the time. So in this problem, let's see. Similar when you guys do exponential, A is the amount like at the end that you would have. P is the starting amount. R is going to be your rate, and we have to make sure that when you guys do your rate, right, if it's like 6%, we need to move it 2 spots to the left, right, make it 0.06. And T is our time. This is only being compounded, and then how many times it's compounded? I think it says compounded monthly, so that would maybe start to say 12. So let's plug in kind of what we know in our formula. What did you guys start with? 5,000. Awesome. All right, so 5,000. We got our 1 plus. Now the rate is 6%, but we don't want to use 6%. You want to change it to a decimal. So 0.06. And how many times are compounded? So compounded monthly, which will be 12. Just be careful up in the top part. We have a 12 up top for the end. But do we know how long we're leaving it in the bank? Okay, so it's all right. So we don't know the actual length of time. They don't tell us how many years. We don't know the T, but at the end, think about it this way. They love these kind of questions, right? For it to double. If you invest 5,000, you want it to double. What do you think? 10,000. But the ending amount needs to be 10,000. So they don't come right out and say this, right? But kind of they like to do that, like have it double or triple or something like that. Okay. Now we're trying to get the T. Any ideas what we need to do first? Okay, we can simplify that now if you want. Alright, yeah. Let's try it. Very cool. Let's try this part first. Fraction first and then add 1, yep. 0.06 divided by 12. Yeah, you just want to make sure your pen depth is okay and then add 1. I like that idea. Makes it a little bit like neater when we're doing some of the work. So 1.005. What do you guys think then? Your goal is to get that little exponent. What do you think you have to get a loan? Okay, yeah. Very good. We should divide by something. We want to get the base by itself. Your goal is to get like this part right here alone. Okay, so whatever the exponent's connected to, that needs to be alone first. Divide by what? By 5,000 again. Let's divide by 5,000. What's 10,000 divided by 5,000? 2,000. Oh, sorry, just 2. I don't know. I'll say that. So 2 equals 1.005 to 12C. All right. No. No, not 10. No, or well, if you guys have a variable or like the letters in the exponent, one thing you guys could do is try to get these numbers to be the same. Is there any way we're going to make a 2 and a 1.005 the same thing? I don't think so. That'd be pretty cool. Okay. So what we have to do is take the log of both sides. Kind of like what we did in that one little problem in the beginning. If you guys take the log of both sides, well, what would this thing, where would this go? Goes to the front. So we get this, 12T equals, right. So I don't know if it would come out to be the same thing. Can I do this real quick? I know what you're saying because there's logs with a single one on each side. I don't think, let me just double check. I don't think it will. I don't think it will. Sorry, guys. Yeah, it comes out totally different. Because I think it's because it wasn't set up originally, like, and then you're turning it into it. Like, it wasn't like a multiplication star. It just comes out to be totally different stuff. But what you can do is then, see how there's no variables, there's no letters in there, right? So if you guys are trying to get just this 12t by itself, like how are these joined together? Multiplication. So how would you start moving things away? Divide. Good. So if I divide by log 1.005, those are going to go away. And we can use this part. So we actually type this right into our calculator. Log 2 divided by 2 divided by log 1.005. So this whole thing equals 12t. Which is the last step? Divided by 12. Yep, so divided by 12. And then t would have to equal, oh, here's 10th, right? So here's 10th of the year, 11.6. Yep. Do you guys remember doing those? We haven't done them in a long time though, but they were hard. Just for time purposes, this one's kind of the same exact deal. So I'm not going to cover that one, but I want to make sure you get to the LNs and E's.
Wasn't there almost like a different formula?
Oh, you're thinking like KE to the RT? Maybe. So that's like the LN.
Okay.
Yep, that's going to be kind of like what this stuff is. Right. The other way that you guys would be seeing anything with like this log chapter come up is the use of like LNs and E's. And you guys have been really good all year remembering that LNs and E's, they're inverses of each other and they're used to cancel each other out. So if you guys have an E and you're trying to find X, what are you going to have to use eventually? LN, good, nice Ashlyn. Right? If you have an LN, we're going to have to be using a E eventually to cancel things out. So the big thing that you guys want to remember when you are trying to get rid of like LNs or E's is that we need to get that part alone first. So in here, we need to get this E to the X alone, right? You got to get this part alone. How would you guys do that? Subtract 8, good job. Alright, so let's see, we have 2e to the x equals 12 minus 8 is going to give me 4. Can we keep going? Can we get e to the x alone?
Yeah, you do that one.
Good job, divide by 2. So we get e to the x equals 2. Right? Now once you guys have that e to the x alone, what you're going to be doing is taking the ln of both sides. Okay? Where would this x really go to? Yeah, like basically what happens, I mean, the x goes to the front, and when you take the ln of e, it's just 1. It like cancels each other out. So now we have x equals the ln of 2. And can you figure out what the ln of 2 is on a calculator? Yeah, so just click your ln button, right up here, and do ln of 2, and it would equal like 0.69. That works. X equals 0.69. I've seen more of this stuff come up lately than I ever have before. A lot of these E's and L's things. We've been doing more often. So for example 2, what we want to do is get this ln x by itself. So move some stuff away. Which hopefully you might see down. So 2 ln x equals -1. And then we have to divide by 2. Yeah, good. Right. So to get rid of the ln, what we're going to have to use is e. Yep. So we're going to do e to the both sides. Now e to that ln, those are going to go away. Right. To get this part in your calculator, your e button is actually the same as the ln, so second ln. And then you would just have to type in that -1/2.
Please excuse the interruption. If Riley Clements is in the building, report to the main office at this time. Riley Clements.
Wait, 6 one? Did you guys find that key okay? I should have had like a better thing with rounding, but it's just whatever they ask me for. Like I never just say half to tell you where to round. If you don't, write the whole thing. I gotta tell you. Okay. Right, this is a little bit tricky. Alright, this time, what is the ln attached to? Is it just the x, just the 3, or both? Both, because of the parentheses. So we have to get this part alone. So we divide by 4, okay, good job. Great. So we have ln of 3x equals 2. So, I mean, we have more stuff than just x here, but we still needed to get that ln alone, so we did. And so now to get rid of the ln, we're going to have to use e. With the e to the ln, those are going to go away. So we just have 3x equals e squared. So let's figure out what this e squared is going to be. And so your e squared. There we go, e squared. You get this number. Now that really equals those 3x. 7, 3, 8, 9. Well, what you guys have to do next here? The divide by 3. Perfect. So divided by 3. And then here's how you would get your 2.46. That's everything. It's a lot of stuff involved, like way more than the other chapters, I think, how they ask you guys.